What's going on, guys? Let's look at this problem right here. This question is asking find the solution of the given initial value problem, and here we have a differential equation with some initial values. And if you look at this differential equation, that's matching with this pattern. This is a linear second order differential equation with constant coefficients. So this is also a linear second order differential equation with constant coefficients. And when we have that one, what we can do is we can use this characteristic equation to figure out our real roots. Now in order to do that, we have to know what our a, b, c values. Here a value is 1, b is 4, and c is 3. Now let's plug the values in this characteristic equation. That's going to be r square plus 4r plus 3 is equal to 0. Now let's see whether we can factor this one. So when we multiply, we have to get 3. When we add, we have to get 4. So 3 plus 1 will work, right? So r plus 3 and r plus 1 is going to be the factors, and that's equal to 0. From this one we can see that r is equal to negative 3 and r is equal to negative 1. Okay, so since we are getting two different real roots, so two distinct real roots, the general solution of this differential equation is going to be this one. Y of x is equal to c1 e power r1x plus c2 e power r2x, and let's say this is r1, this is r2. Okay, now what we have to do is we can write our general solution, that is y of x is equal to c1 e power r1, that's going to be negative 3x, and c2 is going to be e power r2, that's going to be negative x. Now this is our general solution, but when we have the initial values, we have to find out the particular solution. To find out the particular solution, we have to know what is the c1 and c2 values are. To find that one out, we apply this initial conditions, right? Here they have given that y of 0 is equal to 2, and if this is 2, and if you plug 0 for x values, this is going to become e power 0. So c1 e power 0 plus c2 e power 0, so that's going to give us 2 is equal to c1 plus c2 is equal to 2. Now from this one we cannot do anything because we have two unknown variables, so we cannot solve anything. Now let's see what happens if we plug this initial condition, y prime of 0 is equal to negative 1. To do that, we have to find the derivative of this one first. Now let's find the derivative. Y prime of x is going to be, derivative of this one is going to be negative 3c1 e power negative 3x, and then here we are going to have negative c2 e power negative x, and let's apply this equation, and y of 0 is negative 1, and if you plug 0 for this one, this is going to be negative 3 c1 e power 0 minus c2 e power 0, and e power 0 is 1, so this is going to be just negative 1 is equal to negative 3 c1 minus c2, and from this one we cannot do anything, but one thing we can do, we can bring this equation, let's say this is equation 1, equation 2. I bring this equation 1 here, and you can see that c1 plus c2, if we add these two together, this c2 will be eliminated, so this one becomes minus 2 c1 is equal to plus 1, so this c1 is going to be negative half. Okay, now we have found out c1. Now to find out c2, what we can do is we can plug this c1 in this equation and solve for c2. So 2 is equal to negative half from this one. 2 is equal to negative half plus c2, therefore c2 is going to be positive half if I move to the other side. So 2 plus positive half, that's going to be 2.5, that is same as 5 over 2. Right, now we have c1 and c2. Now we can write our particular solution. So particular solution for this differential equation is going to be y of x is equal to c1 value is negative half, So this is going to be negative half e power negative 3x, and C2 value is 5 over 2 plus 5 over 2 e power negative x, and this is going to be the particular solution for this differential equation, and that's how we do this kind of problems. I hope this helps. Thanks for watching.